All right, let's talk about something that is quite literally running our entire digital world, but most of us never even think about it. API security. And look, we're not going to treat this like some dry technical manual. Nope. Today, we're going to think of it as building a digital fortress.
So let me just ask you this right out of the gate. Is your digital front door unlocked? Because, every single time you use an app on your phone, you are walking through dozens of these doors. The real question is, who else might be walking in like behind you?
Okay, so let's break this down. At its very core, an API, that's an application programming interface, it's basically like a waiter for the internet. You tell your app you want to see your messages, right? That's your order. The API takes that request to the server, and then it brings back the right dish, your data. It's simple, it's efficient, and it is absolutely essential. But, and this is a big but, here's the problem. An unsecured API, that's like a waiter who will serve anyone, give them anything they ask for from the kitchen, and never, ever think to check an ID. And that's exactly why today we're going to build a fortress around our API. And every good fortress starts with a solid plan. Which brings us right to section 1, the security blueprint. See, before you even think about laying a single stone, you've got to know the landscape, you have to understand your weak points, and you need to plan out your defenses. And as our source material puts it, the entire point of this blueprint is to do a risk assessment. I mean, that's just a fancy way of saying you need to understand the specific threats and vulnerabilities for every single door and window in your fortress. You just can't build a generic defense. It has to be tailored to the threats you're actually up against. So how do you actually create this blueprint? Well, it's a 4-step audit process. First, you review all your existing policies. Then, you assess where you might have some compliance gaps. The really crucial 3rd step is to actively test things. You perform tests to find the cracks in your own foundation. And finally, you document everything. That becomes the master plan for your fortress. All right, we've got our blueprint. Now it's time to start building. Let's get into section 2, fortifying the connection. This is all about building those high, strong outer walls that are going to protect everything moving in and out. And the absolute number 1 first rule of building these walls? Encrypt everything. Seriously, no exceptions. In the digital world, this means using protocols like TLS, that's Transport Layer Security, and its older brother, SSL. Their job is to create a secure, private tunnel for all of your data. And this visual just perfectly illustrates the difference. Using standard HTTP is like sending your data on a postcard. I mean, anyone who gets their hands on it can read it, plain as day. But using HTTPS, which is powered by that TLS encryption we were just talking about, is like sending it in a sealed, armored briefcase. This is what prevents those man-in-the-middle attacks, where some bad actor tries to listen in on your connection. Okay, so our walls are up, they're strong. But a fortress is pretty useless without some intelligent guards at the gate, right? So let's move on to section 3, guarding the gateway. It's time to control the flow of traffic. The very first guard we need to post is a gatekeeper we call rate limiting. And its job is simple, but it is so critical. It prevents a massive mob from rushing the entrance all at once and just overwhelming our defenses. It basically controls how many requests can come through in any given period of time. And you know what's really amazing? Just how effective this one simple guard can be. Rate limiting is a primary defense against 2 huge threats. DDoS attacks, that's where someone just floods you with traffic to shut you down, and brute force attacks, where they try to guess a password thousands of times a second. This one gatekeeper helps shut them both down. Okay, so with our gatekeeper managing the crowd, now we can post guards to perform some really detailed inspections on all the traffic that's actually allowed through. This is all about looking inside the packages, not just counting them as they go by. So what are these guards looking for? Well, they're on the hunt for digital contraband. Things like SQL injection, where an attacker tries to trick your database into spilling its secrets, or cross-site scripting, where they try to sneak malicious code into a request. But the guards are also looking for anyone trying to access data they shouldn't. And just as important, they're making sure sensitive data doesn't accidentally leak out.
And that right there is the crucial point. Our guards have 2 very distinct duties. Request validation inspects everything coming in to stop threats from ever getting through the gate. But then there's response validation, which is just as important. It inspects everything going out, making sure your fortress isn't accidentally leaking its own secrets. One stops intruders from getting in, the other stops secrets from getting out.
So we have walls, and we have guards, but what happens at 3 in the morning? What if someone tries to scale the walls when no one's looking? That is why every fortress needs a 24/7 watchtower. Welcome to Section 4, the Vigilant Watchtower. You know, the entire purpose of the watchtower is visibility. It's really simple. You cannot defend against a threat you can't see. By setting up clear logging and monitoring practices, you're giving your security team the eyes and ears they need to spot trouble, hopefully before it turns into a full-blown crisis. And hey, logging isn't just about finding the bad guys, not by a long shot. While threat detection is, the biggest reason we do it, logging is also fundamental for responding to an incident after it happens. Plus, it's often required for regulatory compliance, and it can even help you improve your service just by showing you how people are using it. Now, here's a quick but really vital part of all this vigilance: how your system handles errors. Think about it. If an attacker gets a super detailed error message, it's like you just handed them a map of your fortress's internal layout. Proper error handling gives these generic, unhelpful messages to the outside world, which stops attackers from gaining valuable intel when they're poking at your defenses. So, our fortress is built. It's strong, it's guarded, and it's being watched around the clock. But the work is never, ever done. The battlefield out there is always changing. And that brings us to our final section, adapting to the battlefield. See, security is not a one-time setup. It's a continuous cycle of improvement. You identify a new threat or maybe a control that isn't working right. You implement the fix. Then you assess and test that fix to make sure it actually works and didn't break something else. And then you document the change, updating your fortress blueprint. And then the whole cycle begins again. And this, right here, this is probably the most important takeaway from our entire discussion. A fortress is never truly finished. The threats of tomorrow aren't the same as the threats we're facing today. Security is not a product you can just buy off a shelf. It's a process you have to commit to day in and day out. So I'll just leave you with this thought. Now that you understand the blueprint, the walls, the guards, and the watchtower that go into building a real digital fortress, how much trust do you place in the services you use every single day? How secure do you think their front door really is?